What if I told you that we are on the brink of a medical revolution where organ failure might no longer be a death sentence? Welcome to the miraculous world of three-dimensional printed organs for transplantation. In today's video, we're diving deep into this groundbreaking technology that promises to transform the future of healthcare. But before we begin, don't forget to subscribe to our channel, like this video, and hit the notification bell so you don't miss out on our latest content. Also, let us know your thoughts and questions in the comments section below. We'd love to hear from you. Three-dimensional printing, commonly known as 3D printing, is an innovative technology that has rapidly evolved over the past few decades. Initially, it was used mainly for creating prototypes and small-scale models. However, it soon found applications in a wide array of industries, from automotive to aerospace to healthcare. In the realm of medicine, one of the most exciting and potentially life-saving applications of 3D printing is the creation of organs for transplantation. Imagine a world where patients no longer have to wait on long transplant lists, hoping for a compatible donor to save their lives. Instead, they could receive a custom-made organ created from their own cells, significantly reducing the risk of rejection and dramatically increasing the availability of organs. This isn't science fiction. It's a rapidly approaching reality thanks to advancements in bioprinting. Bioprinting is a specialized form of 3D printing that uses biological materials such as cells and growth factors to create tissue-like structures. The process begins by taking cells from the patient, which are then cultured and multiplied in a laboratory. These cells are combined with a bio-ink, a gel-like substance that provides the necessary structure and support for the cells to grow and form tissue. The bio-ink is loaded into a 3D printer, which creates the organ layer by layer, following a precise digital blueprint. One of the key advantages of using a patient's own cells is that it significantly reduces the risk of organ rejection. In traditional transplants, the recipient's immune system often recognizes the donated organ as foreign and attacks it, leading to complications and the need for lifelong immunosuppressive drugs. With bioprinted organs, this risk is minimized, as the organ is made from the patient's own cells, making it nearly identical to their original tissue. The process of bioprinting organs is highly complex and requires a multidisciplinary approach involving experts in biology, engineering, materials science, and medicine. The first step is to create a detailed digital model of the organ, which is based on imaging data from the patient, such as CT scans or MRI scans. This model serves as the blueprint for the 3D printer, guiding the precise placement of cells and bio-ink to recreate the organ structure. One of the earliest successes in bioprinting was the creation of simple tissues such as skin and cartilage. These early achievements laid the groundwork for more complex structures, leading to the successful bioprinting of small, functional organs such as blood vessels and heart valve. Researchers are now working on scaling up these techniques to create larger and more complex organs such as kidneys, livers, and hearts. For example, researchers at Wake Forest Institute for Regenerative Medicine have made significant strides in bioprinting technology. They developed a bioprinter capable of creating a variety of tissues and organ structures, including bones, muscles, and even mini organs, known as organoids. These organoids are not full-sized organs, but are small, functional units that mimic the behavior of larger organs. They are invaluable for studying disease, testing new drugs, and developing new treatments. Another groundbreaking development came from a team at Tel Aviv University who successfully bioprinted a small, functional heart using human cells. Although this heart is not yet suitable for transplantation, it represents a significant step forward in the quest to create fully functional, transplantable organs. The heart included blood vessels, chambers, and other essential structures, demonstrating the potential of bioprinting to create complex organs. One of the most significant challenges in bioprinting organs is ensuring that they have the necessary blood supply to sustain the cells and keep the tissue alive. Blood vessels are crucial for delivering oxygen and nutrients to the cells and removing waste products. Creating a network of blood vessels within a bioprinted organ is a complex and ongoing area of research. Scientists are exploring various techniques, such as printing tiny channels within the bio-ink that can later be lined with endothelial cells to form blood vessels. Another challenge is ensuring that the bioprinted organ functions correctly once it is transplanted into the patient. Organs are highly complex structures with intricate networks of cells, tissues, and blood vessels. Bioprinting must replicate this complexity to create a functional organ. Researchers are developing advanced bioprinting techniques such as multi-material printing and the use of bioreactors to create more complex and functional tissues. Despite these challenges, the potential benefits of bioprinted organs are immense. They could dramatically reduce the need for organ donors, improve patient outcomes, and reduce healthcare costs. For example, the cost of kidney dialysis, a common treatment for patients with kidney failure, can be tens of thousands of dollars per year. A bioprinted kidney could eliminate the need for dialysis, improving the patient's quality of life and reducing healthcare costs. The potential applications of bioprinting extend beyond organ transplantation. Bioprinted tissues and organs can be used for drug testing and disease modeling, providing more accurate and reliable results than traditional methods. For example, a bioprinted liver can be used to test the toxicity of new drugs, reducing the need for animal testing and improving the safety and efficacy of new treatments. Bioprinting also has the potential to revolutionize regenerative medicine. By creating custom-made tissues and organs, it could be possible to repair or replace damaged tissue in patients with chronic diseases or injuries. For example, bioprinted cartilage could be used to treat patients with arthritis, while bioprinted skin could be used to treat burn victims. As with any groundbreaking technology, there are ethical and regulatory considerations to address. The use of bioprinted organs raises important questions about consent, ownership, and access. Who owns the cells used to create the organ? How should the technology be regulated to ensure safety and efficacy? How can we ensure that bioprinted organs are accessible to all patients, regardless of their socio-economic status? Addressing these questions will require collaboration between scientists, ethicists, policymakers, and the public. It is essential to develop a regulatory framework that ensures the safety and efficacy of bioprinted organs while also addressing ethical concerns and promoting equitable access. In conclusion, the potential of three-dimensional printed organs for transplantation is truly revolutionary. This technology has the potential to save countless lives, improve patient outcomes, and reduce healthcare costs. While there are still challenges to overcome, the progress made so far is incredibly promising. Researchers around the world are working tirelessly to bring this technology from the lab to the clinic, and the future of medicine looks brighter than ever. Thank you for joining us on this journey into the future of healthcare. If you enjoyed this video, please subscribe to our channel, like this video, and hit the notification bell so you don't miss out on our latest content. Also, share your thoughts and questions in the comments section below. We'd love to hear from you.